Photogrammetry is a technology that can guarantee high scanning performance in terms of dimensional accuracy and process repeatability. It is not a new technology. It was developed in the industrial sector and has been used in this field for at least 40 years. We are talking about an extremely consolidated, developed and mature technology. In the dental sector, photogrammetry can work alongside an intraoral camera to compensate for its poor accuracy when working on extensive restorations, especially on implants. The presence of tissue between one implant and another, as we all know, always causes imprecision in the location of the implants, if you work with the intraoral camera alone. And imprecision then translates into remakes, adjustments, various tests that must be done in the patient's mouth. In essence, it translates into lost time and money, and an unsatisfied patient. Photogrammetry avoids all of this. The dental photogrammetry system today consists of a package composed of a photogrammetric scanner, a sort of camera that you see in the slide on the left, special photogrammetric scan abutments that are scan abutments with photogrammetric targets on their surface, which are mounted directly in the oral cavity in correspondence with the implants. And then a software that manages the hardware in all scanning phases, that allows the data to be processed to locate with extreme accuracy the position of the photogrammetric targets, thus of the scan abutments, and consequently to obtain with extreme accuracy the positions of the implants on which the same photogrammetric scan abutments are mounted. Here you have 3 dots, developed by OpenTech 3D, a company with 25 years of experience in the development of 3D technologies. In 3 dots we mount high-resolution 12-megapixel cameras, and for them we use the most advanced calibration algorithms to guarantee a dimensional accuracy of 5 microns and a repeatability of 2. The software was developed based on 15 years of experience that we have in the dental sector. It is available with both a free mode and a guided procedure and can directly interact with all CAD available on the market today. In line with all the solutions developed in OpenTech 3D, 3Dots is an open and free tool, which can be interfaced with any intraoral camera, capable of exporting files in open format, STL, OBJ, or PLY. 3 dots alone is not enough. Photogrammetric scan abutments are needed. We all know that the scan abutment is an extremely important component, as important as the scanner. The dimensional accuracy with which we locate the implant is strictly linked to the accuracy with which we create the scan abutment, as well as the accuracy with which the scanner acquires it. OpenTech 3D, since its beginning, has developed precision scan abutments for desktop scanners, so scan abutments for acquisitions on models or impressions. Now we have also developed a family of scan abutments for photogrammetry, compatible with the most used implant platforms. You can see some of them shown in the image in the slide. Today we have both single-component scan abutments and two-component scan abutments. The two-component scan abutments, made of 2 components that must be mounted one above the other, were developed as an evolution of the single-component version, to help those who have not very high performance intraoral cameras with a not too high scanning depth, with which it would be difficult to scan the single component scan abutment. How does the integration of any intraoral camera with 3 dots work? We add simply 2 scans to the normal work protocol. One scan taken with the intraoral camera and one taken with 3 dots. First, as usual, we perform all the acquisitions that we have always done inside the oral cavity regarding tissues, antagonists, healthy parts, everything we have always done. We continue to do. In addition, we add 2 scans. The first is obtained with the intraoral camera. In the case of scan abutments with a double component, we mount the implant bases on the implants. See an example image in the slide at the top right. We scan this situation directly in the patient's mouth via the intraoral camera. In this case, the implant bases have a shape that facilitates the intraoral scan. There is no need to take strange paths, there is no need to acquire too much data. We facilitate the intraoral camera and we also improve its performance. As a second step, without dismantling the implant bases, we place the photogrammetric references on top of them, the cubes with the dots that you see mounted in the image on the left, and we acquire these photogrammetric references with 3 dots. We take the extraoral scan with 3 dots and we obtain the real positions of the implant connections. Let's also see how 3 dots works from a software point of view. As an example, we work on a free project rather than to follow a guided procedure where we would have an interface that tells us exactly what to do in each single step. In this example, we work on a model with 6 mounted scan abutments, and what we are seeing now are the real scanning times. In these few seconds, we scan the position of 6 scan abutments. Later on, we will see that they do not change if we scan in the oral cavity. Now, we give the software a library reference, and in just a few seconds, again, we can place the 6 implant connections, we can locate the 6 implant connections with extreme precision in space. These are our 6 acquisitions. These are the 6 connections placed with extreme precision. In a short time, thanks to photogrammetry, we have our 6 connections located with an accuracy that we cannot achieve with an intraoral camera. However, this data is not sufficient if I want to model a restoration. I have to import other data from the intraoral camera that help me in the modeling phase. Here, for example, I have imported the scan of the tissue made with the intraoral camera. But I could import also the antagonist, the occlusion, the healthy parts, everything I want to import. Of course, this data coming from a tool that is not photogrammetry is not aligned with the photogrammetry data. We can see it well. The scan of the tissue is in one point in space, while the photogrammetric scan is somewhere else entirely. This software allows us to realign this data with each other. Here we are moving all together, not individually, because we want to keep the relative positions unchanged. We move all together the 6 red implant positions, which are those provided by photogrammetry, on the scan provided by the intraoral camera. We have achieved the alignment, so we find that our 6 positions coming from photogrammetry are now perfectly aligned with the tissue that come from the intraoral camera. And then we could do everything with the other data coming from the intraoral camera. We virtually build the patient's mouth. Once the work is finished, we are ready to export it to CAD. During the export phase, the software replaces the implant positions that we got from the scan done with the intraoral camera with the implant positions acquired through photogrammetry. So, in the CAD, I find all the data coming from the intraoral camera in terms of tissues, adjacent, antagonist, and so on. but I work on the implant positions that are provided by photogrammetry. Since the first modeling, I am sure that I work on very precise implant positions. We talked about 5 microns of accuracy. How can we verify it? Actually, it would not be necessary, because anyone who knows about photogrammetry outside of the dental sector knows what kind of accuracy photogrammetry can lead to. However, if we still want to verify the accuracy, the best way is to work outside the mouth. We created a reference model as the one we show in the slide, where we have a certain number of well-fixed analogs. This reference model is touched, is measured with a precision machine like the one you see in the slide on the left, a coordinate measuring machine that is able to give us the true positions of our analogs. The coordinate measuring machine is a machine widely used at an industrial level and is the reference when we talk about accuracy. This machine can reach very, very high accuracies. By touching the model with the probe of the coordinate measuring machine, we are sure to have the true positions of our analogs. True within a few microns of accuracy, a few microns, very little. Therefore, we create a reference against which we will then compare the data coming from the intraoral camera and the data coming from photogrammetry. The next step is to mount the 6 photogrammetric scan abutments on the model, on the analogs. And look on the left of the slide, we will scan them with the intraoral camera to obtain the 6 implant positions. And then look on the right of the slide, we scan them with photogrammetry to obtain the 6 implant positions given by photogrammetry via the software. Therefore, we have 3 groups of implant positions. The reference one that comes from the probe from the coordinate measuring machine, the one that comes from the processing done on the data of the intraoral camera, and the one that comes from photogrammetry. Let's now compare the data with each other. On the left, you see the comparison between the implant positions coming from the intraoral camera with the reference provided by the coordinate measuring machine. On the right, you see the comparison between the implant positions coming from 3 dots, coming from photogrammetry, again with the reference obtained by the coordinate measuring machine. The coordinate measuring machine acts as a reference for both. We compare both our sets of data with the ones obtained with the probe. Green is more or less 5 microns. Red is more than 100 microns. Blue is less than 100 microns. You can immediately see that in the image on the left we have a lot of red and a lot of blue. In the image on the right instead we have a lot of green, which means that with photogrammetry we are within 5 microns practically everywhere. The data that come from the intraoral camera used alone are much more imprecise than those that come from photogrammetry. And I would like to add a consideration. We used the intraoral camera on a model. Why did we work on a model? Because to create a reliable reference, the one created with the coordinate measuring machine, we cannot avoid working on a model. We couldn't measure a patient's mouth with a probe. We needed an extremely reliable reference, so we had to work on a model. And we worked on a model with the intraoral camera, which is a fairly ideal situation for any intraoral camera. We well know that what is rigid on the model in the mouth is a tissue, and tissue is deformable. Then in the mouth we have blood and saliva. On the model instead we have neither blood nor saliva. So the situation we have in the mouth is worse, way worse than the one we have on the model. If we would be able to do the same test in the mouth, we would expect the image on the left to be much redder and much bluer. Instead, on the photogrammetry side, scanning on the model or scanning in the mouth does not influence the quality of the results. Because with photogrammetry, I don't even see the gum, the tissue, the main cause of inaccuracy of the intraoral camera. The same goes for saliva or blood. With photogrammetry, I don't even see them. Moreover, with photogrammetry, I always acquire the complete scene in just a few shots. While with the intraoral camera, to scan an entire arch, I have to acquire hundreds of individual scans that the software has to put together. So, in summary, if we could do the same test in the mouth, again, it's not possible because a coordinate measuring machine cannot work in the mouth, but if we could do, we would end up with the image on the left related to the data provided by the intraoral camera much redder and much bluer, and the image on the right coming from photogrammetry with the same green. So, what are the advantages of using photogrammetry, of using 3 dots in combination to support an intraoral camera? Well, we remove all the various prototypes and test pieces. We do not have to make anything in aluminum. We go straight to produce the structure that goes in the mouth. We do not have to take strange rigid impressions to try to eliminate the error coming from the intraoral camera. We do not have to build peculiar structures to facilitate intraoral scanners. We reduce chair time, we cut some sessions, because we do not have to do several tests in the patient's mouth. In essence, we save money, we save time, and the patient is happier. Let's quickly look at a real case. 6 implants in the upper jaw. We mounted the 6 scan abutments. With the intraoral camera, we acquired everything that we have always acquired with the intraoral camera. And in addition, we have also acquired the tissue with the scan abutments mounted. And we got ready for the scan done with the 3 dots. Here we see 3 dots in action. These are the real times of photogrammetry, of the photogrammetric acquisition. It's done. Just a few seconds. Let me show you how the software works. From left to right, you can see the evolution of the acquisition. On the left, we have some small groups of red or yellow points. Red means that there are not enough points within the group. Yellow means that there are enough points, but we could improve the acquisition. As the software acquires, it adds points to the group. So red becomes yellow, yellow becomes green. When all the groups are green, and that is what we see happening as we move in the slide from left to right, we have completed our scan. Let's also see how the scan is managed within the software. As one scan abutment covered another, we scanned twice. In the second acquisition, we removed the scan abutment that covered the other. So we have 2 groups of scans, one where we have 6 scan abutments, but one is partial, the other where we have 5 because we removed one. The software allows us to align them simply with a click. We obtain a merge scan of the 2, where we have all 6 scan abutments. We clean it, which is an option given by the software. And we do what we did in the previous example on the model. We find the position of the 6 implants. By associating the library, in a very short time, we have the 6 implant connections positioned with photogrammetry. If we want, at this point, we can import all the data that comes from the intraoral camera. So tissues, adhesion, antagonist, everything that we have scanned with the intraoral camera. And working, again, by overlaps, alignments, we build the patient's mouth. I have already said it before, but I repeat it now. When we export to CAD, the software will only keep the implant positions coming from photogrammetry. The implant positions coming from the intraoral scan are not even considered. In the CAD, we can model on implant positions that are very faithful to reality, very, very precise. And in addition, we have the support of all the other data that comes from the intraoral scan. This is the structure milled directly in titanium and tried in the mouth. We did not follow the usual process. We did not create aluminum samples. From the only scan done with photogrammetry, we directly produced the titanium bar, tried in the mouth. And these are the verification X-rays. I repeat a single photogrammetric scan in order to obtain a single titanium milling of the final object. We cut all the test phases that involved the creation of a bunch of aluminum or other material samples. I hope I have been clear enough. Thank you for your attention, and I greet everyone.